Okay, here's the deal. Find the slope of these. If you remember from before, we had already done this in class with you guys as far as slope goes. But there's the formula again. So if you do it, I start doing it that way. I recommend doing it that way so that you don't drop a negative like Aziza did. So it's -3 over 3, which is -1. Okay, that's the first one. Right, second one. 1 over -2, -1/2, same thing. Third one. Negative over negative is just a positive, so it's that. Next one. One over -5. There you go. Any questions on that? On the fifth one, Aziza, what mistake did she make? Should be -1. She dropped a negative somewhere. Made a mistake. Okay. All right. Previously, we had discussed parallel lines, right? And how angles relate to parallel lines, which ones are congruent, which ones, how we label them, how we talk about them, whether they're corresponding angles, various things like that, the names of how they relate, not just whether they're equal, whether they're supplementary, that type of thing, whether they make a linear pair, all of those things. But all about parallel lines. We're going to also extend that to writing equations of parallel lines that are on the coordinate grid. And that's what we're going to talk today. There's two ways to do that, okay? I'm going to show you both ways. I prefer using point-slope form. Raise your hand if you had Mr. Dirks. Mr. Dirks, okay. All of you that had Mr. Dirks have not seen point-slope form, which is perfectly fine. The way you do it is actually easier for some folks, which is fine, okay? So I've got to do it both ways in class. If you did not have Mr. Dirks, just don't pay attention to the second way, okay? You don't have to learn both ways. You're not expected to learn both ways. You're expected to answer the question to the problem, okay? So just figure out how to do it with one of those two ways. So if it confuses you that I'm going to go through two ways, just delete one of them from your mind when I do it. That's all. No problem. I will show my answer keys as in the first version. Okay, point-slope form, if you remember, of a line is y minus y1 equals m times x minus x1, where m is the slope of the line, and where x1, y1 as an ordered pair is a point on the line. Okay. That's all point-slope form. If you don't recognize that, you likely will use just the second method. Okay. Slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line, which is a specific kind of point. It's still a point on the line, but a specific kind of point where the graph intersects the y-axis. It's a very specific type of point. If you remember, the equation of a line is a rule that generates all of the xy pairs that line up in a specific line or in a specific spot on the coordinate grid. Or it's the rule that generates all the xy pairs that fit on the line when you draw it on the coordinate pair. That's what it is. That's the goal. Okay, so we're going to give you characteristics of that line, and we're going to want you to write the equation of the line. Why would we have you do that? Well, because we want you to create the rule or write the rule that generates any and all points within that line or on that line. Okay, that's the goal. And again, this relates specifically back to what we did the previous few days. We're talking about parallel lines specifically. Okay, and we're going to throw in some perpendicular stuff because we did some perpendicular things as well. Okay, so I'm going to do two examples for you in class. After I finish those two examples, you and your role partner are going to work through that second worksheet I brought you. And in order to learn today, you're going to have to do a lot today. You're going to have to pace yourself. You're going to have to answer the question. And if you can't answer them yourself, that's fine. You just come back and ask me instead. Okay? That's kind of where we're going to be at. Anyway. Okay, on example 1, to write the equation of a line when you're given 2 points, that's the setup of this situation. This situation, I give you 2 points that are on that line, and I ask you to find, or never mind, I got ahead of myself. It's because I wrote it like this. Anyways, I give you a point on the line, and I give you a slope on that line. Okay, and I'm asking you to write the equation of that line. Okay, the specific equation that generates all the other points, not just this particular point. If you do it, if you did not have Mr. Dirks, you used, for the most part, you used this formula. You used point-slope form to generate the equation of the line. The way that you do that is x1, y1 are a point on the line. So what we're going to do is we're going to say that this is x1 and that's y1, and we're going to put them into those 2 spots. Okay, and then we know that this being the slope is m, so we're going to put that in the spot where m is. And we're just going to fit those in, and then we're going to solve it for y. So we're going to fit those in. So y1, I said, was 3 as labeled. M is -1/2. x1, I had -2. So it fits into the formula like that. Okay, point-slope form, point-slope formula. So it fits into the formula like that. So now what we need to do is we need to distribute and just solve it for y. And then we'll have the equation in the line. Distribute y minus 3 equals -1/2. And that becomes plus, right? Negative is plus.
Yes.
So -1/2 times +2 is going to be it's going to be -1. Okay. And then we solve for y, so we're going to add 2. So we get y equals -1/2 x plus 1. Okay? That final response at the very bottom is going to be it. So apparently, guys, I added 2 for some strange reason. I need to add 3 there. I don't know why that was the case. So you need to actually add 3. My bad. So it should be plus 2. That's better. Okay. Now let's go back. Let's do the next one. Okay. Or do it the next way, the way that Mr. Dirks winds up doing it. He takes y equals mx plus b, and he'll take the slope and put it in there for m, which is great. Okay. And then instead of x and y, he'll put 3 and -2 in those spots. So instead of y, he'll put 3, and instead of x, he'll put -2, and that way you can solve for b when you work through it, and then you can stick them back in. So for instance, -1/2 times -2 is going to be 1, and then I'm going to -1 from both sides, and you get b is 2, b being the y-intercept. Okay, then from that we have our y-intercept, and we have our slope, and we can put them back in point-slope form. Just stick them in there and rewrite it, leaving x and y as is. And we can write the equation line. We get to the same spot. Okay, so it's mx plus b. Okay.
No, not that.
Up here.
Yeah. Well, no. The one below that.
This one.
Yes, that one.
Gotcha. Okay, let's do example 2 now. I'll do this both ways. Pick the way that you like better, that you can learn easier for you. Okay? Ignore the second version of it that you don't like. Okay? All right, find the equation line that passes through the point -1,5 and is parallel to this line. This gets more into geometry, talking about parallel lines. Parallel lines have the same slope. Because parallel lines have the same slope, we need to look at this line right here. This is not the line we're talking about, we're worried about. We're not worried about this line at all. We just look at this to find the slope because this problem says that the new line is parallel to this line. So we look at this line and say that the slope is 2/5. That tells us that the parallel slope, if you reference what we did on Friday, meaning that parallel lines have the same slope, then the parallel slope is going to be 2/5. Then we have our slope and a point, and we can write the equation of the line that way. Anytime you write the equation of the line, you have to have a point and a slope. Some type of point on that line and the slope. Okay? Or you need to be able to generate the slope. In this second example, we have generated the slope through the calculation. Okay, so I'm gonna do it 2 ways. Here's the first way. using point float form, which is the way I'm primarily going to use. We put in the slope and the point that is on that line, and we generate the equation for the rest of the points. Add 5 to both sides. 2/5 times 1. We get that from looking at we get 2/5 being the parallel slope to this line. Okay, and parallel slopes have the same slope. So that's our equation that way. If you want to do it the other way, I'll show it to you real fast. Either way is perfectly fine. 5 being y, x being -1, b, we're solving for it, and the slope being 2/5. So we get 5 equals -2/5 plus b, add 2/5 to both sides, and we get 27/5 again. And then we take these two and put it into here. Point slope form again, put it in the formula. 2/5 x plus 27/5. Again, same way. Okay, guys, as promised, I'm going to give you an explanation for these guys down here. First, the fact that in this situation, you find the equation of a line that goes through the point 2, -3, and is perpendicular to that line. Again, you need two things to write the equation of a line. You need a point and a slope. We're given this point, check. We are not given the slope directly, so we need to find the slope. We're given information that is perpendicular to this line right here, and we know from on Friday that perpendicular slopes have slope, or perpendicular lines have slopes that are opposite reciprocals. So the slope of this particular line is -2/5. We want the slope of the line that's perpendicular to that, so we want opposite reciprocal to -2/5, which is going to be, flip it and change the sign, which is going to be 5/2. After we do that, we take 5/2 and we put it in slope-intercept or point slope form, and we crank it out. Whereas x1 is 2, y1 is -3. We put those in their spots. We get a -2 there, a little typo at first, and put in our m, our slope of 5/2 or 5/2. Then we multiply it out, simplify, and we get y equals 5/2x minus 8. Then on B, we go scribbled out a little bit. We still want you to do the work. Here, first we're given information that it's a line parallel to this line, in particular, and this point. So we have a point. We don't have a slope yet, and we can't actually read the slope from just looking at this. We actually have to solve it for y first before we turn around and crank it out. So solve it for y. We add 3x to both sides, divide by 2, and we get this y equals 3/2 x plus 5. But we only need that to find the slope, and we want the perpendicular, or the parallel slope to it. So the parallel slope is the exact same. So it's 3/2. Now that we have a slope and a point, we can write the equation using point slope form or any other way. To put 3/2 in for m, we put 4 in for x, and right here, and we put 7 in for y right there, and then we distribute. Okay, and 3/2 times x, 3/2 x, 3/2 times 4 is -6. Okay, and then we add 7 to both sides, and we wind up getting y equals 3/2 x plus 1.